Alrighty, let's see what we got here. Implement router is medium. Design a data structure that can efficiently manage data packets in a network router. Each data packet consists of the following attributes. There's a source, a unique identifier for the machine that generated the packet, a destination for the target machine, and a timestamp. Implement the router class. Takes in some memory limit integer, which is the maximum number of packets the router can store at any given time. Okay. And then if adding a new packet would exceed this limit, the oldest packet must be removed. Okay, so it seems like it'd be a heap if you want to do that. If you want to track that, the oldest, and then bool add packet adds a packet with the given attributes. A packet is considered a duplicate if another packet with the same source and destination timestamp already. Same source, destination, and timestamp already exists in the router. Interesting. Has to be the exact same of everything. Return true if the packet is successfully added. Otherwise, return false. And there's an int. Oh, forward packet returns a integer array. Forwards the next packet first in, first out order. Removes the packet from the storage. Return the packet as an array. Source, destination, timestamp. If there are no packets to forward, return an empty array. Get count returns the number of packets currently stored in the router and not yet forwarded. Have this specify destination and have timestamps in the inclusive range. Note that queries for add packets may be made in increasing order of timestamp. Will be made in increasing order of timestamp. Okay, pretty complicated, I think. Fairly a lot of parts here. Router 3 is the maximum limit of packets. Add a packet. Source is 1, destination is 4, timestamp is 90. Add packet, source is 2, destination is 5, timestamp is 90. Add packet, source is 1, destination 4, 90. This is a duplicate. And the duplicate would make this return false. Add packet, source 3, destination 5, timestamp 95. Add packet, source 4, destination 5, timestamp 105. Okay, so what's going to happen here? 1, 2. So 1, 2, 3. So that'd be the maximum. If it's filled, then what happens? All this packet will be removed. So this one would cause this thing to be removed. And then forward packet would forward the next packet. So it would cause 2, 5, 90, that packet to be removed, so the packets would be 3 and 4 at that point. And then add packet 5 to 110. This is forward packet, add packet, get count. Get count is returns the number of packets stored in the router that have the specified destination and timestamp in the included range. So this is destination of 5. In between 100 and 110, so it should return these two. Returns the number of packets, so it should return 2. No, returns 1. 2590. Okay, the forward thing returns 2590 at that point. Oh, 100 to 110. The timestamp here is outside of that, so it just returns the 4. So there's only one packet that's in that range. Okay, interesting. Let me think here. Returns the number of packets stored in the router have the specified destination at timestamps in the inclusive range. Well, okay, I was originally thinking heap, but here this is actually strictly. This might just be a queue because the timestamps do come in order. Yeah. So I think I use a double-ended queue here. Double-ended queue. I generally call those decks for the pronunciation, or call the variable deck. You know, it's spelled DQ. I'll call cap the memory limit. Yeah, I guess that's fine. Okay. Add packet adds a packet with the given attributes to the router. Returns true if the packet is successfully added, otherwise return false. Well, to quickly determine if the packet's already in there, since it could be anywhere in there, I think I need to have a set probably. So packet set and double check to see if this is already in the thing or in the set. So if the tuple created from source, destination, and timestamp is already in the packet set, and then return false. Return false if it's already in there. Otherwise, I'm going to do self.packetSet, add the tuple that is the source, destination, timestamp, and then adding new packet would, if an adding new packet would exceed this limit, the oldest packet must be removed. So if the current size of the memory of packets is filled, then I need to remove it, remove the top. So if the length of self.deck is equal to the memory limit, then take the oldest out. That would be source destination timestamp is equal to self.dec.popLeft, which is going to be the start of the queue, the double-ended queue. And I think I need to remove this from the packet set. I also need to remove it from the things that are connected to this destination, maybe. I'll worry about that in a bit. Self.packetSet remove. I wonder if I could just store this as a tuple. Maybe I'll call this old info. Oldest info. Yeah, I guess it's oldest packet. Okay. Okay, now I can add the new packet to the thing. Self.packetSet.add source destination timestamp. Wonder if I should just make a... No, I'm not adding this to the packet. I need to add this to the queue. Yeah, maybe I should make a tuple, a variable tuple for this. I'll say new packet is source destination timestamp. If this new packet is in the packet set, then return false. Eventually this needs to return true. Add the new packet to the packet set. If the current length is full, take the oldest out, remove the oldest packet, and then this is supposed to be the deck appends to put it on the end of the queue. This should just be the new packet. Okay. Forward packet forwards the next packet, removes the packet from storage, returns an array. If there are no packets to forward, returns an empty array. Okay. So I'll do the check for the empty array first. If the length of the deck is 0, return this. Otherwise, there should be should be something there. Remove the packet from storage. Okay. Self.packetSet remove. And then return an array that is old packet 0, old packet 1. Okay. I wonder if I can convert, actually, maybe I can just convert this to a list. Convert full to list. I think I just cast it, right? Use the tuple as, yeah, constructor parameter. Okay, and then That's fine. Get count returns the number of packets currently stored in the router that have the specified destination, timestamps, and inclusive range. Now this might be a little tricky to do quickly. So I assume you don't want to do this in time O of n time. Yeah. Yeah, you don't want to do this in O of n time. That just takes too slow. So the main question is how to do this quickly. Timestamp. Get the count of the packets stored in the router that have a specified destination. Have the specified destination and timestamps and inclusive range. So I guess I could I could have an array. I can have each destination mapped to an array of timestamps. Each destination maps to an array of timestamps. That work? Each destination maps to an array of timestamps, and then that array is sorted. I guess that array probably needs to be a double-ended queue as well. A sorted double-ended queue timestamps. And then I do a search in that array for the start time and end time to see what indices those appear at. Yeah, okay. So I'll say get count is the most difficult method to handle, since it can be very slow to try to identify the number of packets given arbitrarily given large number of packets slash times to timestamps to iterate through if going linearly. So here, idea. So possibly possibly use a mapping of destination to queue of timestamps to make searching for start and end times faster. That'd be O of log n to search through a sorted array. Okay, I think I can probably handle that. Self dot we'll call this destination packets, and this will be a default dictionary of lists. And this will map destination to queue of timestamps. Okay, and the times and a queue timestamps is or a deck is initially a list, I think. The internal structure is a list, I believe. Be wrong. Yeah, I think I use a default dictionary of lists. Okay. So when I add a packet, assuming it's not a duplicate packet, I want to take out the oldest packet if it's at memory list, which would also take out that timestamp from the destination packets for that destination. Self dot destination packets, where the destination is the old packet index 1, and then I'll pop left. Since this is the oldest, it should be the first of the deck there. And then adding this thing would be self dot destination packets for the new packet at index, or I guess I can just use destination as the key here. Append timestamp. And then forward packet, same deal. I need to remove the old packet and then self dot destination packets for the old packet index 1 as the destination, pop left. Okay. And then here get count. I think I just use splice, no, not splice. What was that method called? What was that method called? Really slow tonight. Is it bisect? Bisect left. Array value indices. Okay. So I'm going to search for start time, and I search for, I think, end time plus 1 from the appropriate thing. So start index is going to be bisect underscore left, bisect underscore left. The array is self.destination packets of this destination. That's the deck list. Index, or the value to search for, is the start time value. I guess if this thing is empty, then I just return 0 probably. If length of self.destination packets for this destination is 0, return 0. Okay. So bisect left, that returns the earliest index. It would return where start time would be inserted into the list of timestamps here, which is like if the timestamps were 1, 2, 3, 4 and you're searching for 2, then it would be where 2 is found, the index where 2 is found amongst that list of 1, 2, 3, 4. And then end index that I want would be the one after where end time is found, because it's inclusive of end time. So bisect left self.destination packets of destination end time plus 1. And then the difference between those would be the number of packets. Okay, I think that should be right. Well, we'll see. We'll see here. Router object has no attribute memory limit. Oh, it's supposed to be called cap. Pop left is not usable. Really? It's treating it as a list object, but I guess I need to actually treat it as a... Does this actually work? DQ? Python default dictionary of double-ended Q. I guess it does. Okay. My bad. Was not aware. Guess that's different than heaps. Okay. Okay, that worked. Pretty slow though. Really? Not really, not... It's actually very slow, I think. I thought this would be pretty fast. That would be pretty fast. Guess I could do bisect left from the start index here. So the parameters for bisect left is the array, the value that you're searching for, and the low value and the high value. If you have any of those optional parameters. So I can use low value as the start index to make the search slightly faster. But I don't think this is going to improve very much. Well, it actually made it worse. Excellent, excellent. Nothing like optimizations that make things worse. What could possibly be slowing this down? I'm discarding the packets from the packet set when I'm removing stuff from the queue, which I think is correct. Otherwise, the memory just increases over time, which is not good. But my memory is still pretty bad. Packet set append. Top left. Create the list. Add a packet. Sorry there. Turn false. Add packet set. If worry at the top, pop. First in, first out. That should be a queue. Should be a stack. Append. Append. Append the new packet. Append the timestamp. Honestly thought this would be pretty fast. Queries for add packet will be made in increasing order of timestamp. Memory limit is 10 to the 5th. So it should be a pretty big queue. At most 10 to the 5th calls will be made to add packet, forward packet, and get count methods all together. Queries for add packet will be made in increasing order of timestamps. Source destination is going to be 2 times 10 to the 5th. Huh. Alright, I'm going to go get one hint here. Okay, that's not really helpful. Use binary search for counting packets within a time. Okay. Well, those hints were perhaps already implemented. really don't know how this could be made faster. I mean, it doesn't make sense to make this into an array of decks. I think it's probably better to use a dictionary in case you don't need certain indices or certain destination IDs. I think. I mean, maybe you don't need the packet set. Maybe you need the packet set if you can somehow know what the interesting. So here 1490, 1490. I guess add packet never goes backwards in time, but there could be simultaneous packets that occur. Add packet. Let me see. Adds a packet with the given attributes. Queries for add packet will be made at increasing order of timestamps. So I really only care about packets of the current timestamp. Because if it's a higher timestamp, then I know it can't be a duplicate. So I don't need to have a set of all packets in the queue. I just need to have a set of packets that have the current timestamp, like the latest timestamp. So interesting. Okay. So here I think I'm gonna have self.latest or latest set, which is the latest packets with timestamps with latest timestamps. So if I have, I think maybe I'll also have a latest time. Is that necessary? Maybe not, maybe not. Okay, so if the timestamp, so how should I do this? If there is something in the deck, so if self.deck and the last timestamp matches the current timestamp of this add packet, self.deck, last thing, the timestamp for it. Deck is a queue. I'm taking the last element of the queue. The timestamp should be the second indexed value, so that's the third thing in that tuple. Matches this timestamp. Matches this timestamp. And that should mean that the latest set should be comparable here. And actually, so the new packet's going to just be a tuple that is source and destination. and new packet is in self.latestSet, then this means it's a duplicate. And then I just need to remove this packet set. Otherwise, this can be otherwise, it could be one of two things. It could be an empty latest set, or it could be a new timestamp. So if it matches the timestamp, okay, I just need an if statement here. If self.dec and self.dec matches the current timestamp. Oh gosh, what is the logic here? What is the logic here? If it's an empty thing, then I automatically add it. And I also need to create a new. I need to create a new set. So here, if it's empty, if there's nothing there, oh gosh. So I need to reset the latest set. Okay. Clear my mind here. I have a packet. I need to check to see if this packet already exists in the latest set. But that only occurs if the timestamp is appropriate. Timestamp is appropriate if there is something in the deck, and that something in the deck's latest thing has a timestamp that matches this timestamp. So I think I do something like this. If self.dec and or if it's empty, if not self.dec, and or if it isn't empty but the last thing is different, the last timestamp is different, then create a new latest set. Okay. So now I'm guaranteed to have a latest set. Okay. And then I can just say if this packet is in the latest set, then return false. Okay, otherwise I do the whole creation of the packet or adding the packet into the latest set. Add it to the thing. Take out the oldest one. Is this necessary? No. I wonder. Can you forward a packet and then add a packet that has the same timestamp? I guess you can. Okay, old packet. I guess if the current time, if the current time of this, if this current thing that pops from the queue matches the timestamp of the latest thing, then it should still be in the same latest set. So if old packet, the timestamp on it matches self.dec, the last thing's time, then I need to do self.latestSet.remove a tuple that is the old packet source and destination. This old packet here has both the source, destination, and timestamp, but the latest set only has tuples of source and destination. Maybe I should just have source, destination, timestamp in the latest set as well. Would make this slightly more consistent, even though the timestamp is maybe unnecessary. Okay, let's do that. Okay, so the new packet has source, destination, timestamp. If there's an if it's not empty dec, which would mean that there is some timestamp to work with. And the time is different. Although maybe I can just use if not self.latestSet, really. That's fine though. So if new packet has later time, reset latest set of packets, which has older time. So if the new packet is already in the latest set, then return false. Add it. And then if the packet time, I could just use discard, self.latestSet.discard. So I don't have to do a check here. If the timestamps match or don't match, it doesn't matter. Sure. So discard is it might or might not be there, and remove is it has to be there, I believe. Remove returns an error if it's not there. Discard does it. Discard the old packet. Where the old packet is popping left, the first thing from the deck and then popping left the destination packets. Pen the new packet. Pen that timestamp. Same thing here. This should be self.packetset.discard. Okay, maybe this works. Line 33. This should be latest set. Okay. Wow, all that for nothing. Okay. Huh. New packet has a later time reset latest set packets. Well, in theory that should have been an optimization. If the new packet is already in, then return false. Add the new packet. And then remove the old packet. Yeah, I don't know. I don't know what would make this faster. I guess this optional parameter didn't really help anything. Oh, my fastest thing was the first time I ran it. It's like 44%. It's getting worse. Alright, I'm gonna see what the difference between this and something a lot of notes. Forward packet, pop left, remove forward packet, pop left, remove from destination dictionaries. I don't think this was necessary to bisect it because you can just pop it from the left. This should be It should be the earliest thing in the destination dictionary queue. Yeah. Destination not in self.destination. Okay. I think I just used length of it is 0. I wonder. Is that actually, because this thing could possibly make this this could create a destination dictionary deck if it's not there. So I guess I can do another condition here, like if destination not in the destination dictionary. Or the length of that, if there is a dictionary or there is a deck there. I mean, that's the only thing that I saw that seemed to be faster, maybe. Since it didn't, default dictionary would automatically create a deck. Do. sin self. It's Is a double in a queue? No, I think I need that. Do I need that? I guess I don't. Okay. I mean, that cannot possibly be anything. Cannot possibly be anything. Latest set. New packet. Double check. Latest set reset. It's already there. Ignore. I guess I can do this first. No, can I do this first? No. Yeah, I can do it first, sure. The timestamp information is there. Reset the latest set if it's a different timestamp. Add the packet. If it's capped, take out the left side. They do have a mapping of destinations to a list, right? Also, we need to remove packets from dictionary. Well, it's not a default dictionary. It's not a default dictionary. Okay. How closely do I want to just the dictionary to get count? Destination not in self. So they don't use a default dictionary, but they do kind of manually add it. I don't think that matters. Alright, see something slightly slower, but still faster. My god, it's just a lot of... I honestly don't know. I think what I had originally was fine. Get count destination. Yeah, this just gave me no benefit there. I guess they use end time or the end time plus 1. I think it should be, well, they use bisect left. What times do they use bisect right? I use bisect right. Alright, whatever. Alright, summary. So, you know, this is what to say about this? Since the packets are already ordered, processed, added sess process. with increasing times. Naturally will use a double-ended queue. Structure to quickly add and quickly do first in, first out ordering or processing. Need to maintain some sort of set to also prevent duplicate packets from entering the queue. Lastly, for quick counting of relevant packets given queries by destination, start and end times. Also need to maintain a sorted array, or in this case a double-ended queue as well, for each destination, which I use a default dictionary of queues. To an binary search to find times / indices, times within that, where delta, or the difference in indices of search equals the count of queries that match that. So yeah, bisect left, or bisect left, bisect right, using start and times. Adding the packets, making sure it's not already there. Here I just did a slight optimization that didn't optimize anything, or didn't actually seem to be relevant, which was the latest set of packets was matching the current timestamps for those packets. Otherwise it resets the latest set of packets, where the latest set of packets is the one that could be duplicated. Anyways, time complexity, this can be O of 1, no. Time complexity, I guess this can be O of 1 for constructor, for adding a packet, O of 1 for adding packets. Since we're using a double-ended queue, which has constant access to the first and last, and constant appending to the last. O of O of 1 for forward packet, since again the DQ has constant access to the front, which is the oldest packet, and then O of log n for forward packet. No, for get count, since the need to search through sorted array. Note that due to adding packets by user or by whatever is already in sorted order, sorted timestamp order. There is no kind of O of n log n cost to sorting any of this. Space complexity is going to be O of kind of the number of packets, I want to say. Max packets, since everything is capped to that value and will need information for those relevant packets in storage.